Hi friends, I am Balaji Rao. Welcome to BR Max class. I saw many students, they feel difficult to memorize all the trigonometry formulas. This trigonometry not only useful in trigonometry chapter, we use these formulas very frequently in calculus also. Many students feel difficult. What is this trigonometry? What formulas these are? How difficult to remember all these formulas? So I felt that I want to create a video which is one-stop solution for all the students who want to learn trigonometry formulas. So in all these things, first video takes some time to explain all the things in detail. Only the mistake that students will do is they don't sit and they won't focus more to understand all the formulas. In this video, what I did, all the main formulas I kept at one place so that you can easily understand what is happening. Only thing what I'll say, have patience. Spend 1.5 hour time to learn all trigonometry formulas. This is one-stop solution. After this 1.5 hour, you will never say that I am feeling difficulty in trigonometry formulas. That is my guarantee. Let's start the class. First, we will learn the definitions of all 6 trigonometric functions. For that, you need to observe few things in this diagram. You see, I considered a circle with center O and radius R. This is the circle with center O and radius R. You observe two things here, OA, OP. OA is the initial side. If I rotate OA through an angle theta, then OP is formed. Now, I'll draw PB, which is perpendicular to OA. Now you can observe the triangle OPB. OPB is a right angle triangle. You observe the triangle OPB. What is PB? PB is opposite side of an angle theta. And PB is also Y. You see here, what is Y? Y is PB. We know that in a right angle triangle, the opposite side of 90 degrees is hypotenuse. See, this is 90 degrees now. What about OP? OP is a side opposite to 90 degrees. So OP is hypotenuse. Opposite side over, hypotenuse is over. What is the remaining? That is OB. What is OB? OB is adjacent side. Once we consider all these things, then the 6 trigonometric functions are defined as follows. What is sine theta? Sine theta is defined as opposite side of an angle theta divided by hypotenuse. See, this formula works only for right angle triangle. For here, what is theta? Theta can be taken as any angle. Here theta is a real number actually. So in such case, this formula is very useful. Actually, Y is opposite side, R is hypotenuse. So you learn the definition of sine theta. What is sine theta? Opposite side of an angle theta divided by hypotenuse. Sine theta can also be written as Y by R. Okay. Now, how the cos theta is defined? Cos theta is defined as adjacent side divided by hypotenuse. What is adjacent side here? Adjacent side is OB. That is X divided by hypotenuse is R. Sin theta is defined as Y by R. Cos theta is defined as X by R. Now what is tan theta? Tan theta is defined as opposite side of an angle theta divided by adjacent side. In this triangle, what is opposite side? Opposite side is Y. What is adjacent side? Adjacent side is X. So what is tan theta? Tan theta is opposite side by adjacent side, which is also known as Y by X. Cot theta, how it is defined? It is defined as adjacent side divided by opposite side. What is adjacent side as per the diagram? Adjacent side is X. Opposite side is Y. So tan theta is defined as Y by X. Cot theta is defined as X by Y. Cosecant theta. Cosec theta is defined as, you can see here, cosecant theta is the reciprocal of sin theta. So cosecant theta is defined as, it is the definition. How it is defined? Hypotenuse by opposite side. What is hypotenuse? Hypotenuse is R divided by opposite side. What is opposite side? Opposite side is Y. Secant theta is defined as hypotenuse by adjacent side. Hypotenuse is R. R divided by adjacent side is X. Okay, we will quickly revise all these formulas. What is sin theta? Y by R. What is cos theta? X by R. What is tan theta? Y by X. What is cot theta? Cot theta is reciprocal of tan. Cot theta is x by y. What is cosec theta? Cosec theta is reciprocal of sine. Sine theta is y by r. Cosecant theta will be r by y. What is secant theta? Secant theta is r by x. Now we will learn reciprocal formulas. Sin theta formula is 1 divided by cosec theta. From this we can easily write what is cosecant theta. You see, you take cosecant to this side and sine to this side. Okay, then what is cosec theta? Cosec theta is 1 divided by sin theta. So if you know one, other one you can write easily. Sin theta is what? 1 by cosec theta. What is cosec theta? If I cross multiply this, cosec theta is 1 by sin theta. So here cos theta can be written as 1 divided by secant theta. If you cross multiply this, you will get secant theta. What is secant theta? Secant theta is 1 by cos theta. Okay. Tan theta. Tan theta reciprocal is 1 by cot theta. Cot theta is 1 divided by tan theta. Okay. These are 6 reciprocal formulas. Here you need to note a point. What is that note point? Tan theta. See here, tan theta is 1 by cot theta. Na? Tan theta is 1 by cot theta. Tan theta can also be written as sin theta divided by cos theta. Okay. And similarly, what is cot theta? Cot theta can be written as cos theta divided by sin theta. Okay. So we learn 2 set of formulas in this trigonometry till now. Now we will see the third set. This is important one. Try to understand this clearly. Okay. You see, here I considered a coordinate axis. This is which quadrant? We know that this is first quadrant. This is which quadrant? This is second quadrant. Good. This is which quadrant? This is third quadrant. Right. What about this? This is fourth quadrant. Right. So here we have 4 quadrants. First quadrant angle range is what? Is 0 degrees to 90 degrees. Correct? Okay. If I write this in radian measure, it will be like this. First quadrant angle range is 0 to pi by 2. It means that 45 degrees lies in which quadrant? First quadrant. 60 degrees lies in which quadrant? First quadrant. 70 degrees lies in which quadrant? First quadrant. So first quadrant angle range is 0 to 90 degrees. Okay. And important thing is, in first quadrant, all trigonometric functions are positive. In pi by 2 minus theta lies in which quadrant? Pi by 2 minus theta. What is theta here? Theta is acute angle. Acute angle means you know it is an angle in between 0 to 90 degrees. Pi by 2 minus theta lies in which quadrant? It lies in first quadrant. You see here, pi by 2 minus theta. If theta is any acute angle, I will take pi by 3. Pi by 3 means 60 degrees. 90 degrees minus 60 degrees is 30 degrees. That is pi by 6. You see, pi by 6 means 30 degrees. 30 degrees is lies in first quadrant only. Na? So what I am trying to say, pi by 2 minus theta lies in first quadrant. Now few more points are there. I will discuss those things. Now we will move to the second quadrant. What is the angle range of second quadrant? The angle range of second quadrant is 90 degrees to 180 degrees. This is the angle range of second quadrant. And when I write the same thing in radian measure, 90 degrees means pi by 2, 180 degrees means pi. So if I take an angle 130 degrees, it lies in which quadrant? It lies in second quadrant. Angle 150 degrees, it lies in second quadrant. Angle 179 degrees, it lies in second quadrant. Angle 60 degrees, is in first quadrant. Okay. Now, when it comes to trigonometric functions, what trigonometric functions are positive? In second quadrant, sine is positive and cosec, it's reciprocal. Cosec is positive. What about remaining all? Remaining all are negative. In second quadrant, sine theta is positive, cosecant theta is positive. These are the things we use very frequently while solving trigonometric problems. You need to memorize all these things. Pi by 2 plus theta. Here, what is theta? Theta is acute angle. See here, pi by 2 plus theta. Pi by 2 means 90 degrees. Theta is some acute angle. You select any acute angle. For example, you take 30 degrees. 90 degrees plus 30 degrees is 120 degrees. Correct or not? 120 degrees lies in which quadrant? It lies in second quadrant. So what I am trying to say, Pi by 2 plus theta lies in which quadrant? It lies in second quadrant. Similarly, pi minus theta also lies in second quadrant. Pi minus theta, pi means 180 degrees minus theta. Theta is acute angle. You select any acute angle. For example, I'll select 60 degrees. Okay, 180 degrees minus 60 degrees is what? 120 degrees. 120 degrees lies in second quadrant only, na? So, what I am trying to say, this is important. What we are learning now, that is important. Pi by 2 plus theta lies in second quadrant. Pi minus theta also lies in second quadrant. And this box I'll discuss at the end. Okay, now we'll move to the third quadrant. What is the angle range of third quadrant? Angle range of third quadrant is 180 degrees to 270. 180 degrees, if I write the same thing in radian measure, 180 degrees is pi, 270 degrees is 3 pi by 2. So what is the angle range of third quadrant? 180 degrees to 270 degrees. When it comes to what trigonometric functions are positive in third quadrant? In third quadrant, tan function is positive and cot function is positive. What about remaining all? Remaining all are negative. For example, what about sine in third quadrant? In third quadrant, sine is negative. Like that, you need to remember. What are positive in third quadrant? Tan, cot are positive. Remaining all are negative. See, as it is a third quadrant, it lies in between 180 to 270 degrees. Pi plus theta lies in which quadrant? Pi plus theta lies in third quadrant. See here, pi plus theta, here only I will take pi plus theta. Pi means 180. 180 plus 60 is what? 180 plus 60 is 240 degrees. 240 degrees lies in which quadrant? Third quadrant. So 200 degrees lies in which quadrant? Third quadrant. 240 degrees, third quadrant. 260 degrees, third quadrant. What is the angle range of third quadrant? 180 degrees to 270 degrees. Okay. So pi plus theta lies in which quadrant? Pi plus theta lies in third quadrant. Similarly, 3 pi by 2 minus theta. 3 pi by 2 means 270 degrees. 3 pi by 2 minus theta. I'll write here. See, 3 pi by 2 minus theta. 3 pi by 2 means 270 degrees. 270 degrees minus theta is acute angle. You take anything. For example, I'll take 30 degrees. 270 degrees minus 30 degrees is what? It is 240 degrees. 240 degrees lies in which quadrant? Look here. 240 degrees lies in which quadrant? It lies in third quadrant. So, what I am trying to say, pi by 2 plus theta lies in which quadrant? Third quadrant. 3 pi by 2 minus theta lies in which quadrant? Third quadrant. You need to be thorough in all these things. This box I'll discuss at the end. Now, come to the fourth quadrant. What is the angle range of fourth quadrant? Angle range of fourth quadrant is 270 degrees to 360 degrees. So, the angle range of fourth quadrant is 270 degrees to 360 degrees. Same thing if I write in radian measure, 3 pi by 2 means 270 degrees to 360 degrees means 2 pi radians. Now, when it comes to fourth quadrant, see here it's very simple. 3 pi by 2 plus theta. 3 pi by 2 plus theta. Here theta is acute angle. 3 pi by 2 plus theta lies in which quadrant? It lies in fourth quadrant. For example, you can check here. 3 pi by 2 plus theta. 3 pi by 2 means 270 degrees. Plus you take some acute angle. For example, I'll take 60 degrees. 270 degrees plus 60 degrees is 330 degrees. 330 degrees. 330 degrees lies in which quadrant? Look here. 330 degrees lies in fourth quadrant. Correct? 2 pi minus theta. 2 pi minus theta lies in fourth quadrant. You observe with this example. 2 pi minus theta. 2 pi is 360 degrees. Minus theta is any acute angle. You take theta as 30 degrees. 360 minus 30 degrees is 330 degrees. 330 degrees lies in fourth quadrant. What point you need to remember here? 2 pi minus theta lies in fourth quadrant. 3 pi by 2 plus theta lies in fourth quadrant. You need to memorize these things. Now you come here. 2 pi plus theta. This is important. 2 pi plus theta lies in first quadrant. Actually, you see 0 to 90, 90 to 180, 180 to 270, 270 to 360, 360 to 450 degrees. It lies in which quadrant? 360 degrees to 450 degrees. It lies in again first quadrant. Here, this loop will goes on continuously. Once 360 degrees over, 360 plus theta. If theta is acute angle, it lies in first quadrant only. So, in first quadrant, what angles will be there means pi by 2 minus theta and 2 pi plus theta both lies in first quadrant. Yeah, you see this box. In fourth quadrant, what trigonometric functions are positive? Cos and secant, these things are positive in fourth quadrant. Cos theta, secant theta are positive in fourth quadrant. Okay, look here, you need to be thorough with these things. For example, if I ask pi plus theta lies in which quadrant, you need to say immediately pi plus theta lies in which quadrant? Third quadrant. Pi minus theta lies in which quadrant? Second quadrant. 3 pi by 2 plus theta lies in which quadrant? Fourth quadrant. 2 pi plus theta lies in which quadrant? First quadrant. 2 pi minus theta lies in which quadrant? Fourth quadrant. Like that, you need to practice in such a way that you are thorough in all these formulas. These things we use very frequently while solving trigonometric problems. We will come to these another 4 remaining boxes. See, this is about even number. Generally, 2n represents even number. Even number into pi plus theta. Even number into pi plus theta lies in first quadrant. Even number into pi minus theta lies in fourth quadrant. For example, 6 pi. 6 is even number. 6 pi plus theta lies in which quadrant? It lies in first quadrant. 6 pi minus theta lies in which quadrant? It lies in fourth quadrant. Even number 20 pi plus theta lies in which quadrant? First quadrant. 24 pi minus theta, even number into pi minus theta lies in fourth quadrant. So, even number into pi plus theta, first quadrant. Even number into pi minus theta, fourth quadrant. Now, you see these things, second quadrant. In second quadrant, generally odd number is denoted by 2n plus 1. Odd number into pi minus theta. Odd number into pi minus theta. It lies in second quadrant. Here 2n plus 1 means odd number. 1 into pi minus theta. You see here pi minus theta, like that. See, for example, what I am trying to say, 5 pi minus theta. Odd number into pi minus theta lies in which quadrant? It lies in second quadrant. 7 pi minus theta. It lies in which quadrant? It lies in second quadrant. Like that, odd number into pi minus theta lies in second quadrant. Odd number into pi plus theta, 2n plus 1 into pi plus theta. It lies in which quadrant? It lies in third quadrant. Many students confuse like anything to understand these things. All the information I written at one place. So you please go through all these things. These are very important. Now we will move to fourth set of formulas. In this we will learn sin of minus theta, cos of minus theta, tan of minus theta, all these formulas. What is sin of minus theta? Sin of minus theta is minus sin theta. Tan of minus theta is minus tan theta. Cot of minus theta is minus cot theta. Cosecant of minus theta is minus cosecant theta. You see here for cos secant I written in red color. First point is this minus theta. If theta is acute angle, minus theta lies in fourth quadrant. In fourth quadrant, cos secant, these things are positive, remaining all are negative. That's why cos of minus theta is cos theta. Secant of minus theta is secant theta. You can easily remember these formulas. Cos of minus theta is cos theta. Secant of minus theta is secant theta. Tan of minus theta minus tan theta. Cot of minus theta minus cot theta. Sin of minus theta minus sin theta. Cos of minus theta cos theta. These formulas are very easy to remember. Minus theta lies in fourth quadrant. In fourth quadrant, cos secant only positive. Okay. Now we will move to fifth set of formulas. Fifth set of trigonometry formulas. In this, we will learn about trigonometric identities. We use these trigonometric identities very frequently. Mainly, 3 trigonometric identities are there. From those 3 trigonometric identities, we will get 9 formulas. And at the end, we will learn another 4 identities from these 3 trigonometric identities only. Okay. So first trigonometric identity, sin square theta plus cos square theta equal to 1. This is first trigonometric identity. We use this result very frequently. Sin square theta plus cos square theta equal to 1. From this, we can write another 2 formulas. What is sin square theta from this formula? Sin square theta equal to, you see here, this cos square theta, you take it to the right hand side. Then it will become 1 minus cos square theta. So what is sin square theta? Sin square theta is 1 minus cos square theta. Similarly, you see this sin square theta plus cos square theta equal to 1. From this, we can write cos square theta. What is cos square theta? Cos square theta equal to, you take this sin square theta to right hand side. Then what you will get? 1 minus sin square theta. So sin square theta is 1 minus cos square theta. Cos square theta is 1 minus sin square theta. So you learn 3 formulas. Actually, only this one, if you remember, remaining 2 you can write very easily. What is the main formula in this? Sin square theta plus cos square theta equal to 1. Okay. Second trigonometric identity. 1 plus tan square theta equal to secant square theta. 1 plus tan square theta equal to secant square theta. In this trigonometric identities, you remember that the friend of tan is secant. 1 plus tan square theta is secant square theta. Very frequently used trigonometric identities. From this, you can write what is tan square theta. You see here, you take this plus 1 to right hand side. Then you will get tan square theta equal to secant square theta minus 1. This plus 1 will become minus 1. 1 plus tan square theta is secant square theta. From this, we can write tan square theta. What is tan square theta? Tan square theta is secant square theta minus 1. Now, the main trigonometric identity is 1 plus tan square theta equal to secant square theta. What I'll do now, I'll take tan square theta to the right hand side. Then you see what happened. You see, I taken this tan square theta to the right hand side. Then right hand side will be secant square theta minus tan square theta. What will be remaining? Equal to 1. So secant square theta minus tan square theta is 1. So we learned another 3 formulas, but mainly one formula. 1 plus tan square theta equal to secant square theta. If you know this, remaining 2 you can write very easily. Okay. Now you see third trigonometric identity. 1 plus tan square theta is over now. Now 1 plus cot square theta. 1 plus cot square theta equal to cosecant square theta. From this, we can write cot square theta. What is cot square theta? You just take this plus 1 to right hand side. Cot square theta is cosecant square theta minus 1. So 1 plus cot square theta is cosecant square theta. Cot square theta is cosecant square theta minus 1. If I take cot square theta to the right hand side, then what you will get? You will get this cosecant square theta minus cot square theta equal to 1. See, secant square theta minus tan square theta. It looks like a square minus b square. What is the formula for a square minus b square? A plus b into a minus b. So here what I can write, secant square theta minus tan square theta can be written as secant theta plus tan theta into secant theta minus tan theta equal to 1. Okay. From this, we can easily write what is secant theta plus tan theta. What is secant theta plus tan theta? You take the secant theta minus tan theta to right hand side, then it will goes to the denominator. You will get 1 divided by secant theta minus tan theta. Not only this, you can write secant theta minus tan theta. Secant theta minus tan theta as 1 divided by secant theta plus tan theta. In the same way, we can write for this also. Cosecant square theta minus cot square theta equal to 1. It looks like a square minus b square. So what is the formula here? A square minus b square formula is a plus b into a minus b. So cosecant theta plus cot theta into cosecant theta minus cot theta equal to 1. From this you can write cosecant theta plus cot theta. What is cosecant theta plus cot theta? That equal to 1 divided by cosec theta minus cot theta. These are the formulas we use very frequently. Only the thing is have patience. Practice all these formulas. Now we will go to 6th set of formulas. 6th set of trigonometry formulas. In this, we will learn the values of trigonometric functions from 0 degrees to 360 degrees. I saw so many people are giving tricks to memorize all these formulas. What I feel, the trick is useful when we use these formulas very rarely. At that time, we can use the trick to memorize these formulas. But in trigonometry, we use these formulas very frequently. Best thing is just give some time to learn these formulas. You see here, this table is actually very easy. Only the thing is, you need to memorize this first row and second row, about sine row and cos row. What I am saying here, this trigonometry table is very easy if you are good in these first two rows. Remaining all, you can write from these two rows only. So first we will learn from 0 to 90 degrees and then we will concentrate on 180 to 360 degrees. You see here, first sine 0 is 0. Better you memorize that trigonometry table starts with 0. That means sine 0 value is 0 and sine 90 degrees value is 1 and the middle one is 1 by root 2, that is sine 45 degrees, and sine 30 degrees is 1 by 2, sine 60 degrees is root 3 by 2. You try to learn this row. Yes, I saw so many students, they'll confuse like anything to memorize these values because of lack of practice and because of small technique. What is the technique in this trigonometry table? You learn first two rows. I guarantee you that you can write any value from this trigonometry table. Okay, so you learn that first row, I think so. Sine 0 degrees is 0, sine 90 degrees is 1, sine 45 degrees is 1 by root 2, sine 30 degrees is 1 by 2, sine 60 degrees is root 3 by. Now, when you learn the first one, second one also no need to memorize. It comes reverse of this. You see, 1. Root 3 by 2, 1 by root 2, 1 by 2, 0. But however, it is good idea to memorize these values. See, cos 0 degrees, 1. Cos 45 degrees, 1 by root 2. Cos 90 degrees, 0. Cos 30 degrees, root 3 by 2. Cos 60 degrees, 1 by 2. Just spend 1 minute time. Write it on, take pen, paper and write it. Learn these things. Remaining all, I guarantee you that you can write all those values. Okay. So now you are good with sine row and cos row. Now we know that tan theta is nothing but sine theta by cos theta. Correct. In reciprocal formulas we learn tan theta is nothing but sine theta by cos theta. Correct or not? From this we can write all the values of tan. For example, tan 0 degrees is there. What is tan 0 degrees? Tan 0 degrees is sine 0 degrees by cos 0 degrees. You know sine 0 degrees value, cos 0 degrees value. See, sine 0 degrees divided by cos 0 degrees. 0 by 1. What is 0 by 1? 0 by 1 is 0. You see here 0 is there now. I hope you are understanding. Similarly, tan 30 degrees is what? Tan 30 degrees is sine 30 degrees divided by cos 30 degrees. You see here, sine 30 degrees divided by cos 30 degrees. See, this 1 by 2 will get cancelled. What you will get? You will get 1 by root 3. Correct or not? So, if you want to calculate tan 30 degrees, you just write sine 30 degrees value divided by cos 30 degrees. That's it. You will get it. Okay. Tan 45 degrees. Tan 45 degrees is sine 45 degrees divided by cos 45 degrees. See, this root 2 will get cancelled. 1 by 1 is 1 only. Correct or not? So, tan 45 degrees value is 1. Initially, if you go like this, once you keep on applying these values at particular moment, no need to write like this. You will be thorough in all these values. Please believe me, just need a practice. That's it. Okay. So all other values you can write like that. For example, tan 90 degrees. Tan 90 degrees is what? Sine 90 degrees divided by cos 90 degrees. See, sine 90 degrees divided by cos 90 degrees. 1 by 0 is what? In the denominator 0 means it is not defined. That's why tan 90 degrees is not defined. So if you memorize the sine row, cos row, tan row, you can easily write. Cot theta is cos theta by sine theta. For example, you want cot 0. Cot 0 is what? Cot 0 is cos 0 by sine 0. Cos 0 is what? Cos 0 is 1. Sine 0 is what? Sine 0 is 0. 1 by 0. In the denominator 0 means it is not defined. So what is cot 0 degrees value? Cot 0 degrees value is not defined. I hope you are understanding. Similarly, cot 45 degrees. Cot 45 degrees is what? Cos 45 degrees divided by sine 45 degrees. See, cot 45 degrees. Cot 45 degrees is Cos 45 degrees value is what? 1 by root 2 divided by sin 45 degrees. That is also 1 by root 2. 1 by root 2 divided by 1 by root 2 is 1. Like that, you can write complete this cot row. I hope you are understanding, right? So now cosecant. See this cosecant row. We know that cosecant theta is nothing but 1 by sin theta. Correct? As you learn this first row, you can write all the values of this row. For example, cosecant 0 degrees is there. Cosecant 0 degrees is what? 1 by sin 0 degrees. Sin 0 degrees is 0. 1 by 0 is not defined. See here, cosecant 0 is not defined. Similarly, cosecant 30 degrees. Cosecant 30 degrees is 1 divided by sin 30 degrees. Sin 30 degrees value is 1 by 2. 1 divided by 1 by 2 is 2. You are understanding. So what I am saying, you just memorize sin row and cos row. These two are important. Once you are thorough with these things, whatever the value they give from the trigonometry table, you can write it very easily. Okay. Similarly, this secant also. See here, secant theta. Secant theta is what? Secant theta is 1 divided by cos theta. Here, if you want to find secant 45 degrees, okay, secant 45 degrees is 1 divided by cos 45 degrees. As you learn cos row, cos 45 degrees value is 1 by root 2. 1 divided by 1 by root 2 is root 2. So you see secant 45 degrees is root 2. Right? So if you learn sin row, cos row, remaining all values, you can write very easily. So we learn up to this 90. 180 to 360 also we use frequently. This 180 to 360 also we use frequently, but not as much as from 0 to 9. You check this part. See, 1 0 minus 1 0. Correct or not? It is easy to memorize. 1 0. You start with 90. 1 0 minus 1 0. Here cos row you see it's a reverse order. 0 minus 1. 0 minus 1. 0 1. Cos row. Reverse of sin row. Correct or not? So if you notice this point, that means you learn the sin row as well as cos row. So you can easily write other values. Correct or not? You can write all other things. For example, if you want secant 180 degrees. Okay. What do you know secant 180 degrees? 1 divided by cos 180 degrees. Cos 180 degrees value is what? Cos 180 degrees value is minus 1. So 1 divided by minus 1 is minus 1. You see here secant 180 degrees value is what is there? Minus 1 is there. See, I saw many students, they'll struggle like anything to memorize these values. Actually, my point of view, if anyone asks, the students are not spending time to learn the formulas. Once they start, you just spend half an hour time with the trigonometry values. Only half an hour time. You will be master in these trigonometry values. Only thing is you need to sit, take pen, paper and try to practice these things for a half an hour. That's it. It's over. This is 7th set of trigonometry formulas. In this, we will learn trigonometric ratios of allied angles. To understand this, first you need to understand these three things what are written below here. 1, 2, 3. These three things you need to understand. This we already discussed in 3rd set. First quadrant, all trigonometric functions are positive. And which angles lies in first quadrant? Pi by 2 minus theta, 2 pi plus theta lies in first quadrant. Second quadrant, in this, sin theta, cosecant theta are positive, remaining all are negative. What angles lies in second quadrant? Pi by 2 plus theta, pi minus theta. Third quadrant, in third quadrant, tan cot are positive, remaining all are negative. What angles lies in third quadrant? Pi plus theta, 3 pi by 2 minus theta. Fourth quadrant. Fourth quadrant, cos secant functions are positive, remaining all are negative. What angles lies? 3 pi by 2 plus theta, 2 pi minus theta. These things we already learned. Okay. Now you see the second one. This is important one. In this table, wherever you see 90 degrees to 70 degrees. Wherever you see 90 degrees to 70 degrees, then sin changes to cos, cos changes to sin. Tan changes to cot, cot changes to tan. Secant changes to cosecant. You see here we have 4 columns related to 90 to 70. Correct? Whenever 90, 270 is there, what you know? You know that sine changes to cos, cos changes to sine. Tan changes to cot, cot changes to tan. Secant changes to cosecant, cosecant changes to secant. Here, you see, sine changed to cos, cos changed to sine, tan changed to cot, cot changed to tan, cosecant changes to secant, secant changes to cosecant. You see here also, whenever 270 is there, sine changes to cos, cos changes to sine, tan changes to cot. Correct? You observe those things? Only confusion is when to keep this minus, when to keep minus, when to keep plus. It's a simple thing. For example, you want to know sine 90 degrees minus theta. Suppose you want to know what is sine pi by 2 minus theta. Pi by 2 means 90 degrees. Whenever you see 90 degrees, you just simply write sine as cos theta. You just write sine as cos. Now it became cos theta. Now second thing is we need to keep here sine here, plus sine or minus sine. Pi by 2 minus theta is in which quadrant? You see here, this part. Pi by 2 minus theta is in which quadrant? It is in first quadrant. In first quadrant, what do you know about sine? It is positive or negative. In first quadrant, all are positive. So sine is also positive. So this is plus cos theta. So sine pi by 2 minus theta is cos theta. You see here, that result only we written. Suppose if you want to write cos pi by 2 plus theta. Cos pi by 2 plus theta. What the main point here? First point, when pi by 2 is there, that means 90 degrees. When 90 degrees is there, cos changes to sine. You can look here. Cos changes to sine. So first thing, you write sine theta. Second point, you observe that pi by 2 plus theta, it lies in which quadrant? It lies in second quadrant. You look this part, cos. In second quadrant, cos is positive or negative. You look here only. In second quadrant, cos is positive or negative. In second quadrant, cos is negative. Correct? So cos pi by 2 plus theta is minus sine theta. So you see here cos pi by 2 plus theta, what we written here? We written here minus sine theta. Correct or not? Yes. I hope you are understanding. Now you see something 270 plus theta. Something given like this. Cot is given. Cot 3 pi by 2. Cot 3 pi by 2 plus theta. 3 pi by 2 means 270 degrees. As we discussed, whenever we see 90 degrees, 270 degrees, function changes. Cot changes to tan. Here cot is there. Now cot changes to tan. You just simply write tan theta. Now the point is 3 pi by 2 plus theta lies in which quadrant? You look here. 3 pi by 2 plus theta is in which quadrant? It is in fourth quadrant. In fourth quadrant, cot is what? In fourth quadrant, cot is negative. So simply write minus. So cot 3 pi by 2 plus theta is minus tan theta. So you learn about the second part. Whenever we see pi by 2, 3 pi by 2, what happens? Now we will see another 4 columns. Now you see this third one. Whenever you see 180 degrees, 360 degrees, then the function remains same. Sine remains sine only. Cos, cos only. Tan, tan. Cot, cot. The function won't changes. It remains same. Now you observe there are 4 black color columns are there here. Now we will discuss these things. First thing, sine pi minus theta. Okay. Pi means 180 degrees. Whenever we see 180, 360, function won't change. So we will write sine theta only. Now it's about its sine, plus sine or minus sine. You look here, pi minus theta is in which quadrant? You see here, pi minus theta is in which quadrant? Pi minus theta is in second quadrant. In second quadrant, sine is what? Positive or negative. In second quadrant, you look here. In second quadrant, sine is positive. So this is plus sine theta. Okay. Now we'll go with one more. Cot pi minus theta. Cot pi minus theta. First point, when pi is there, pi means 180 degrees. Whenever 180 degrees, 360 degrees is there, function remains same. So this is cot theta. Right? Second point, pi minus theta is in which quadrant? Pi minus theta is in second quadrant. In second quadrant, cot is what? In second quadrant, cot, this one. In second quadrant, cot is negative. So cot pi minus theta is minus cot theta. You can see here, cot pi minus theta is minus cot theta. You can observe this here, right? So similarly, we'll go with the 2 more examples. Suppose tan 2 pi minus theta. 2 pi minus theta. 2 pi means 360 degrees. 2 into 180. Whenever 180, 360 is there, function remains same. So this is tan theta only. Okay. Now the point is 2 pi minus theta is in which quadrant? Look here. 2 pi minus theta is in which quadrant? It is in fourth quadrant. In fourth quadrant, tan is what? In fourth quadrant, tan is negative. In fourth quadrant, secant cos only positive. In fourth quadrant, tan is negative. So tan 2 pi minus theta is minus tan theta. You see here, tan 2 pi minus theta is minus tan theta. You can observe the answer here. Tan 2 pi minus theta is minus tan theta. I hope you are understanding. Now we will learn 8th set of formulas. Now we will learn domain, range and graphs of trigonometric functions. You see the graph and you tell the domain of this. You observe the x-axis. It is defined everywhere on x-axis. That means the domain of the function is all real numbers. Okay. And what about range? Range of sine function. You can see the graph is in between -1 and +1 only. You can see the sin x values are always in between -1 and +1. You can observe the graph. The graph is in between -1 and +1. The range of this function is closed interval -1, 1. Now come to cos x function. You observe x-axis. Is this function is defined for all real numbers? Yes. What is the domain of this function? Like sine function only, domain is all real numbers. Okay. Range. You observe the values of cos function in this graph. You can observe the graph. The cos values are always in between -1 and +1. It tells you that the range of the function is closed interval -1, Now it comes to tan x function. Tan x can be written as sin x divided by cos x. Whenever this cos x is 0, at that time tan x is not defined. So when cos x is 0, whenever x is odd multiple of pi by 2, cos pi by 2, 0. When cos pi by 2 is 0, this function is not defined. Tan pi by 2 is not defined. So what I am trying to say, when cos x is 0, at that point tan x is not defined. So what is the domain of tan function? So domain of tan function is all real numbers except odd multiple of pi by 2, 2n plus 1 into pi by 2. Here what is n? N is an integer. N is an integer. The range of sine function is all real numbers. Now come to cosecant x. Cosecant x can be written as 1 divided by sin x. Correct? Whenever sin x is 0, then cosecant x is not defined. When sin x is 0, at that time x will be of like this, n pi. Sin pi 0, sin 2 pi 0, sin 3 pi 0, like that. So what is the domain of cosecant function? It's all real numbers except at n pi, where n is an integer. Now what about its range? Range of this function. You can observe this blue color part is the graph. You can see that in between -1 and +1, secant in between -1 and +1, cosecant x graph is not present. Okay, so its range is what? All real numbers. You won't get any values in between -1 and +1 for cosecant x. So range of cosecant function is all real numbers except open interval -1, 1. Okay, it's about secant x. Secant x can be written as 1 by cos x. Yes, correct. Secant x can be written as 1 by cos x. Whenever cos x is 0, then secant x is not defined. Like tan x only. Tan x also sin x by cos x now. Whenever cos x is 0, at that time tan x is not defined. So the domain for tan x, secant x both are same. What is the domain of secant x? Domain of secant x is all real numbers except odd multiple of pi by 2, because whenever cos x is 0, at that time secant x is not defined. From the graph also you can observe whenever pi by 2 is there, 3 pi by 2 is there, there will be a vertical line. At that point the function is not defined. Now we will go to the range. Range of secant x. You see the blue color graph is there now, that is graph of secant x. In between -1 +1, there is no graph of secant x. So what is its range? Its range is all real numbers except open interval -1, 1. Now it's about cot function. Cot x can be written as cos x divided by sin x. Correct? Cot x can be written as cos x divided by sin x. So whenever sin x is 0, cot x is not defined. So you see here for cosecant x also 1 by sin x. Whenever sin x is 0, cosecant x is not defined. So what is the domain of cot x? Domain. I'll write the domain. The domain of cot x is all real numbers except n pi, where n is an integer. Okay. Now it's about range. What is range? Range is all real numbers. You can see the graph. Range is all real numbers. So with this, all the formulas related to trigonometric functions we covered.